function, service switching function. Okay, and then for intelligent peripheral, you see specialized resource function. Okay, then service creation function belonging to the service creation environment. Then the pyramid, the hosting the SCP, you will see it pointing to a service control function under the distributed functional plane. Okay, so the functions that they perform, what function does the SSP perform? What function does the IP perform? What function does the service creation environment perform? What function does the SCP perform? Basically, that is that, as simple as that. And then we move to the global functional plane. So the global functional plane is the one that hosts, the plane that hosts the SIPs that we spoke about. Okay, like I said initially, that the capability sets that is used to define the progression of the IN into phases. Okay, it's made up of the service independent blocks. Okay, so the SIPs is found in the global functional plane. So the SIPs are just programs which are interpreted. Okay, they are just programs. So you will see that the specialized resource function has the user interaction program or the user interaction SIP. What does that mean? User interaction. So if you relate it from the global functional plane all the way to the node, physical node itself, the IP is what plays announcements for or for the customer, IN announcements. So for example, maybe you call and then you hear, please press 1 to whatever, press 2. It's a user interaction, it's interacting with you. Those kind of announcements that you hear is a specialized resource function, okay, which sits on those announcements, sits on the intelligent peripheral. So the programs which are responsible for that is the user interaction SIP, SIB. Okay, so you will see status notification SIP also pointing to the service control function, which is pointing to the SCP. The status notification SIB, status. So your number is bad, is disabled or whatever. So you can just get a notification on your phone and alert that, okay, your number is bad or is disabled, whatever. So it's a status notification which is handled by a particular service independent building block. Okay, so that is for the global functional plane. Then you move to the service plane. So the service plane is basically the service that you are providing. So what service is the physical plane providing at the end of the day? Okay, if it's number portability, is to free, whatever, that service at the end of the day sits on the service plane. So that is that for the IN conceptual model. It's similar to the OSI model. Okay, so that is basically that. All right. Okay. Now, I think I've explained this service plane already. Okay, so let's move on to your global distributor. I've explained all these ones. Okay, so let's quickly move on. So let's see how the functions which sits on the distributed functional plane correlates with the physical plane. Okay, so if you see call control function, the switch does call control. Okay, so when you make a call, the switch will now control the call between the IN back and forth. Okay, so there will be a flow of communication. So it's a call control function. So that function sits with the SSP. Okay, now we have call control agent function. So it provides users with access to the network. Okay, yes. So we also have another function, service switching function. Okay, so when a service is supposed to be pointed to a particular IN node. Okay, so if it's an IN announcement or it's maybe a particular service which is residing on a particular SCP or whatever, the SSP has this function of switching the service. So it's an SSF function. So a service switching function. Okay, so just take note of that. Call control function, service switching function are all sitting with the SSP. Then the SCP, that's service control function. Service control function. So based on service logic programs, it can direct the call processing. All right, so the service control, okay, and then note these subtle nuances. The SSP is service switching. So once you see switching in there, you should just know that, okay, it belongs to the service switching node. Okay, so SSP has service switching. SCP, service control, because the name itself is service control point. So obviously, the service control function will belong to it. Okay, then we have service data function. Okay, so which provides service-related customer and network data for access, and the service SCF during the execution of service logic. So basically, the SDF in some vendors IN, for example, Ericsson have the SDP, service data point. Okay, so that is basically used for the charging. Okay, the useful is that's where the service data, the balance of a subscriber, and some other details or information is sitting. Okay, so at the end of the day, the SCP is what originally was hosting all this information. But I'm just saying that some network, some vendors, IN vendors have the SDP aside SCP, but they all are in the same network, IN network. So service data function belongs to the SCP. Okay. The Huawei will have it as CBP with the online charging system. Okay, so just take note of that. So when you see service, anything service data, service control function belongs to the SCP. Then you have the SMS. Okay, not short message system, that you know. SMS here refers to service management function. So there is actually a platform that helps in provisioning and deployment of IN services and service-related data. So we have third parties connecting to the IN. For example, maybe the network is providing an insurance service. So every month you are deducted a token from your balance. See, so this connection via the TCP/IP protocol usually resides with the service management function, which is on the SMS part of the IN. Okay, so it allows third parties to connect to the IN and provide services. So maybe you can have a trivia service. You can have televoting where you send, you vote for a particular program, or you have jokes being sent to you by another third party. But it's so IN allows those third parties to connect for charging, for service provisioning, and all that. So the service management function handles that. Okay, so service management access function 2 provides the interface for the accessing the service management function. Okay, so on Huawei, they will call it SMAP. SMAP, that node that handles the, which is in the SMS service management area. It's called SMAP. Okay, so just take note of these functions in the distributed functional plane. So if you see service management function, it belongs to the SMS, service management access function. Now take note of these two, service management function and service management access function. So one provides the interface for accessing the SMF. You see, the interface for accessing the service management function is done by the access function, SMAF, SMAF. The SMF itself manages the provisioning and deployment of IN services. That is where the real work is in terms of provisioning, deployment of the services. But if you want to assess that provisioning and deployment, you have to go through the interface is providing, whether it's a web portal or it's whatever. Okay, so that function is done by the service management access function. So take note of that so that you see it anywhere you can really relate to it. And then the service creation environment. Service creation environment. The service creation environment functions, SEF, provides for the creation and validation of new services. So it generates a service logic used by the SEF. Okay, so these are just all residing on the IN. So which is where you create your services, basically. All right, so you generate service, the logic and all that. So you can create the services in that environment. And then IP, like I said, intelligent peripheral is responsible for specialized resource function, which is sitting on the distributed functional plane. Specialized resource functions. So user interactions like announcements, maybe you are trying to reach a number which is not which is disabled, it will play an IN announcement for you. Maybe you bought a scratch card and you have to dial a number to input the tickets. So it will now tell you, okay, key in the digits. So that announcement and user interaction, those voice recognition, sometimes the dual tone, multi-frequency, tones that you type on your phone, those kind of feedback and prompts collect information that is sent back and forth between the customer and the network is handled by the IP. So it's called specialized resource function. All right, specialized resource function. And there are two forms of announcements that's being played on the network. We have the core network announcements, which is generalized announcements for customers, all right, which usually is handled by the media gateway. Yes, Max, I think media gateway handles the core network, the network announcements, right? Yes, and then the specific IN announcements is being played by the IP, the intelligent peripheral. Intelligent peripheral. Okay. Hello, Max, are you there? Hello. Can you all hear me?
Yeah, hello, Farid.
Yes, so I was just trying to tell them the core network announcements or the network announcements usually resides on the media gateway. I hope I'm correct with that.
Yes, you are correct.
Okay, so with IN specific announcements, it's handled by the intelligent peripheral. So take note of that.
Farid,
Yes.
just a gentle reminder.
Okay.
We are, I think we are
Almost.
Yeah, the time
Okay.
is.
Okay.
Yeah, so trying and
wrap up.
put things together here for the module 1.
Okay.
Module 2 is starting at 10.
Okay.
10, yes. So
at 10. Okay.
Yes, yeah.
Okay. Okay. So
is it possible to
I can combine the two.
Okay, how long do you think you can finish? Because there's a different link for the module 2.
Oh, okay.
Yes, we are not using the
there's
same
a different link.
Yes.
Okay, so let me see where the module 2 starts from. Coming. Okay, so it means I have just I'm almost done. Okay, basically good. I've already spoken about it's just the BCSM, the basic call state model that I will just have to go on. Okay. So when I'm done with that, I'm done.
All right. Okay.
Okay. So I'm done with the IN conceptual model. So let's wrap it up with the basic call state model. So if you can just give me some few minutes, I'll wrap this up quickly.
Sure,
Even
sure.
though this one too is quite detailed, but I'll see how best I can summarize it. Okay, so let's jump straight to the basic call state model. Okay, we have touched on the first model, which is the INCM, the Intelligent Network Conceptual Model. Take note of those acronyms. Okay, now we move on to the BCSM, Basic Call State Model. BCSM, Basic Call State Model. All right, so the one key differences between the IN phase 1 and the succeeding IN phases is the introduction of a formal call model. And a call model is basically a definition of call processing steps that are involved in making a call. So if you are making a call, it goes through processes, it goes through stages. Yes, so there is an agreement. There was initially no agreement between vendors on exactly what constituted each stage or phase of a call. Okay, so there had to be a formal call state model which really defines the stages that a call should go through when you are making a call. Okay, that will be standardized across different vendors. So the same call transition states or call state model is applicable to all vendors, Ericsson, Huawei, Alcatel, whichever. Okay, so that is basically it. No complications here. It's just a way that the stages can be clearly delineated, okay, to prevent ambiguity. All right, so the IN defines a basic call state model which identifies the various states of call processing and the points at which IN processing can occur, known as points in call. Okay, so in the BCSM, we have what we call points in call. And the points in call, it's marked by entry and exit events. So this area actually, BCSM, please pay attention. It's quite abstract, but you get it. It's not that difficult. Okay, so before the introduction of IN, there was point in call. The switch was already deploying points in call. What do we mean by points in call? So when you make a call, okay, there's an entry of the call and there's an exit. Okay, so with the introduction of the BCSM, basic call state model on the IN just added detection points to the already existing point in call. So when you make a call, there's a routing information that is sent to the HLR. Okay, so that collection of information from the MSC to the HLR is a point in call. So there's an entry that the MSC sends an information, and there's an exit, that is when the information is returned back to the MSC. So that is a clear example of a point in call trigger or a point in call. Okay, so take note of that. When you make a call, there's a request that is sent to the HLR. That's a clear example of point in call. After the information is fetched from the HLR will now tell the MSC that, I mean, based on the information I sent you, this guy is an IN, the information for charging and everything should be sent to the IN. So after the exit, then there's a detection point, there's a trigger that is going to the IN. So that's the difference. Point in call is the place where there's a collection of information or gathering information by the MSC or the switch, okay? And then there's detection point. After the information is gathered, then based on the analysis of the information, it sends a trigger to the IN, whether for charging or for whatever the IN should do. It will now send a trigger to the IN. Okay, so this is essential for distributing service processing between the SSP and the SCP, because the SCP must identify the PIC, blah, blah, blah. Okay, let's move on because of time. Okay, so with that said, pointing call, like I've already explained, is marked by entry and exit events. So exit events mark the completion of a processing by the current PIC. Okay, so the entry and exit event provides a means of describing what constitutes being in a particular PIC. Okay, all right. So that is that for the PIC. I told you the BCSM is made up of PICs and DPs. DP stands for detection point. Detection point. All right. So look at this diagram very well. So we have a basic call state model. We have a DP and a PIC. DP, PIC. Basically, that is what it entails. The DP is a detection point. The PIC is a point in call, which is marked by entry and exit events. So after a PIC, after it exits a PIC, it now goes to a detection point. So a clear example is what I gave you. Once it gathers the information, it triggers. The DP is just the detection that has to be sent to the IN. Okay, so, all right. So we have the detection point. The DPs between the various PICs represents, so the DPs are sitting in between what the PICs represents points at which IN processing can occur. So the DP detects that the call has reached a particular state as indicated by having exited the previous PIC and encountering the DP. Okay, so basically once an information is gathered, like I said initially, if you make a call, information about the subscriber is gathered from the HLR. That information gathering is called the PIC. It's just one example of it. So once the information has been done gathering the information, the MSC is done gathering the information from the HLR. It has to now, based on the information it gathered, it has to exit or send a request to the IN that, okay, this guy wants to offer this service, a toll-free service. So there's a trigger. So that trigger is called a detection point. So we have, okay, IN processing can be invoked to communicate with SCPs, blah, blah, blah. Okay, so we have the trigger detection point and the event detection point. Take note. Trigger detection point and event detection point. So an example of a trigger detection point is when the MSC sends a request to the IN. Like I told you, the intelligence has been taken from the MSC. So the IN is now in a centralized node database sitting somewhere. So if the MSC was originally doing the service logic by itself, and now it has been taken away from it, then it means that it has to contact the IN somewhere. So the contacting of the IN is what we call the trigger detection. Okay, so the MSC has enough information about whoever is trying to access a particular service, so that after gathering that information and exiting the point in call, it will now trigger the call to the IN. So that is an example of a trigger detection. Okay, good. And then event detection. An event detection point is a point at which the SCP arms an event at the SSP. So what does this mean? Once the TDP or the trigger detection is sent to the IN will look at all these details during the call flows, okay, in the second module. But let me just make some salient points here. The event detection is when the SCP arms an event at the SSP. So SCP can tell the MSC or SSP that, okay, when the number you are trying to reach, okay, is not reachable, or is busy, or maybe something happens at the other leg that I have to be made aware, please notify me. So that is an event detection. So an event happens at the other end because it's the switch that connects the call. It's not the IN. The switch is the one that connects the call and monitors the call. So if something happens on the call, the switch should note it as an event. So that is an event detection. Then after detecting that event that has happened, whether the number is switched off, disconnected, busy, whatever, once it detects it, it should send an information back. So an event detection is just the SCP arming an event at the SSP. So it tells the SSP. The arming just means just tell the SSP to tell me, give me information of whatever is happening on the call. Basically, that is that. So under the event detection EDP, we have two types. We have event detection request and event detection notification. Okay, so the request is the one that is sent to the MSC or the SSP, and the notification is the one that comes back. Okay, so an EDPR is a request that the SSP the SSP stop call processing except in the case of no answer and no answer DPs, and sent an event DPR message to the SCP. Okay, so we'll break it down as we move along with a clear examples. So when we get to the call flows, I'll refer to some of these areas. So just not to confuse you, at least you understand the detection points, which are in two parts: event detection and trigger detection. And then you understand the point in call. So point in call plus detection points together makes up the basic call state model. All right. So that is that. All right. So there's an example of a basic call state model. So number one, you see that triggers are provisioned at SSP, which means SSP gets information from HLR. And then number two, once it gets that information, it triggers the detection points. It generates a message. So you can see the arrow pointing to the SCP. Okay, then the SCP sends back an ADP after the TDP, which is triggered to the SCP. The SCP now sends an event detection. Like it arms a message that, okay, SSP, whatever event you encounter during the call, please notify me. So number three, event armed from the SCP. All right. So then number two, when that event is detected, you can see event Z detected, then the message is sent back. So it's a back and forth. Okay, you detect, then you notify me, detect, notify me, back and forth like that. So in all those things, you have the point in call exiting, getting to a detection point, exiting, getting to a point in call again, exiting to a DP. So it's PIC DP, PIC DP, PIC DP. So at every DP, there's a message, then IN feeds back. So it's just feedback, notification, back and forth between the SSP and the SCP. We'll dive deeper into that as we go to the module 2. So to round up, I think this is the IN architecture and design. I've already explained that already. So we have the SSP, SCP, STPs, and the IP, which is the intelligent peripheral. Okay, so if you have any questions, you can ask so that we bring it to a close.
Okay, so I wanted to ask the previous slide. Assuming you are on a call,
okay,
two scenarios.
Okay.
Your call drops because of bad network.
Okay.
And also your credit finish. How are the communications between the SCPs and the SSPs going to look like for these two scenarios?
Okay, so the first scenario is your call drops, right? And the second scenario is your credit gets finished.
Yes.
Okay. So when we go to the other model, we'll look at what we call apply charging. Okay. So you are given a standard, I know, is every 5 minutes for a typical call to talk. So initially your balance is checked. So if you have, let's say, 10 cedis, 10 Ghana cedis, all right, how much talk time can you use the 10 cedis for? And this will be broken into chunks of 5 minutes each. This will be given to the SCP that for every, the SSP, the switch, MSC, whatever, to monitor the call for 5 minutes. Every 5 minutes, report so that we deduct that 5 minute duration from the balance. Okay, so in the course of monitoring and the call cuts, how much out of a 5 minute chunk did the call? I mean, maybe the guy spoke for 3 minutes. It didn't get to 5 minutes.
Okay, not to cut you, but we are doing per second billing here or in Ghana.
Yes, we are doing per second billing, but per second billing just means that, okay, every 5 minutes will now be broken down into seconds. So 5 times 60 will be how much? 300 seconds, right? So for every second, based on the network, he will now define that every second you should charge the person maybe 1 cedi. Are you getting me? But what I'm trying to say is that you are saying that what if the call drops? And I'm saying that the call is being monitored. So every 5 minutes, the MSC will feed back to the IN. Then the IN, based on the billing calculations done, maybe it's per second or per minute billing, whatever, the duration is reported back. So if the guy spoke for 3 minutes, convert it to seconds and do the deduction from back end. Okay, so whether it's per second, per minute, it doesn't change anything. At the end of the day, the guy spoke for how long before the call cuts. Okay, so as the call is monitored and is fed back, it cut at 3 minutes, it didn't get to 5 minutes, or it cut at 7 minutes, which means that the first 5 minutes has been deducted. The next 5 minutes, he spoke only 2 minutes and the call cuts. So a feedback is brought to the IN. This is done to prevent you from more or less overusing your, so it's prepaid billing. You have 10 minutes, you can speak for 300 seconds. You are broken the 300 seconds in 5 minutes chunks, so you cannot cheat the network. So if your credit finish every 5 minutes, it reports, every 5 minutes, it reports, every 5 minutes, it reports. There's no way once your credit is sourced, the IN will send a release message to the MSC that the guy has finished his credit based on the last duration you sent. So please just cut the call from that side. If the call is cut deliberately by the customer on the other side, then the feedback will still be given that, okay, he didn't finish his credit. He just spoke for this number of minutes. So do the deduction. I don't know whether you are still, is it clear?
Yeah, I get you.
Okay. Any other question? Any other question? Any other question? Okay, so without any question, I think I will bring Module 1 to a close. So is it Prince who asked that question?
This is Kwame.
Okay, so we'll revisit your question when we go to the call flows. It's a very nice question you asked. So with the call flows, you will now really understand, okay, what happens when the call cuts? What happens when, the credit depletes or it gets finished? There's no way, that's the beauty of IN. There's no way you can maybe use your credit at the end of the day, cut the call and then still have your credit intact about it. So just calculate it based on the block chunks. There's no, you have it, working as expected. Any other question? The IN conceptual model, BCSM, the pointing call, the detection point, the I mean, whatever question that you think you have, you can ask. Without any question, I think I'll bring the session to an end, the module 1 to a close. Thank you very much. And I'll meet you in the second module, which is an hour time from here. Oh, Max, when is the second module?
Hello, Farid. Yes.
Yeah.
So the second module will start now. It's supposed to start now from 10.
Okay. All right. Okay. Okay.
So I will share the link. I'll share the link.
Okay.
You can join.
Okay. Sure. Okay.
All right. So guys, thank you for joining the module 1 of the INIC. And we'll meet in the module 2. I'll share the link shortly with you all.